So you may remember me before lunch. Glad you're still here. My name is Doug Blank. I teach computer science at Bryn Mawr College. I've been using Python for a long time, a couple of decades. Ooh, yeah. I was introduced to Python through a student, so it's good to listen to students. They have good ideas often. I worked in a project 15 years ago that combined Python and robotics. It was called Pyro before there was another Pyro. So I got really familiar with Python, but ironically, I haven't been able to use Python for a while. We used Python in the introductory courses at Bryn Mawr for a while, but we switched to processing. Have you heard of processing? Processing is a nice little system that takes Java and makes it sort of look like Python. So you don't have to use any of the public static void main. Because we use processing, I had to create a processing kernel so I could use Jupyter with that in our introductory courses. In fact, for the last 4 years, I've used nothing but Jupyter in the classroom. And I teach a variety of classes, including first-year writing courses, assembly language, Scheme, if you know Scheme. I teach programming languages. But I've only been able to use Python recently when I teach with the data scientist in the other departments of Python, physics, and in biology. So let's see, what else did I say? Yeah, I said that. If you go to the next slide, I'll just point to a bunch of pictures that sort of represent different levels of extensions that I've done using Jupyter over the last 4 years. And I guess these are all I would consider experiments. I have a little Jeopardy processing project there in the center that I use as not only an example of using the language that we're learning, but it's a nice review. So we actually play Jeopardy in class as a review. There's no money involved. So I guess the one thing I'd like to say that relates to this panel is the talk that I gave at Jupyter Day Philly, which was an entire Jupyter Day just about education. There are lots of interesting talks. I think we'll have some URLs later that point to that. And there are lots of interesting talks from a variety of people on education. But the talk that I gave there was about storytelling with Jupyter. And at a small liberal arts, I'm really interested in bringing computation up to the same level as reading and writing. So I'm trying to get the college to buy into the idea that it's not crazy to actually have first-year students write a little bit of code, maybe using something like Plotly, to do a little bit of graphs, to visualize data that they might also be writing in. So learning a little bit of writing, a little bit of reading, and then combining that using, of course, the power that you all know about Jupyter. That was an interesting experiment. You know, you learn a lot even with failures. And maybe I can talk a little bit about that. But I guess I'll just say that using Jupyter Notebook, students don't necessarily pick up instantaneously. They actually need to be taught how to use Jupyter and the idea that you need to insert cells. You're supposed to insert cells. You're supposed to play around. You're supposed to try different parameters. That's something that I found you really have to teach them how to do that. So that's good. Oh, we all have microphones now. Good.
Hi, so I'm Taylor Martin. I'm at O'Reilly Media, and just to change a little bit of focus, instead of thinking about how Jupyter's helping us with computation and visualization, things like that, I'm going to talk a little bit how it helps with infrastructure. So, you know, everybody knows what Jupyter Hub is, but you know, at O'Reilly, we're working on using Jupyter Hub to be able to have people spin up all the compute resources and get to the data that they need for our trainings quickly and without any hassle whatsoever. So when I started getting ready to teach my data science class, my data engineering class in the data science program at Berkeley, I started thinking, well, you know, what are we going to do? Because we really have to get people to go from nothing, like no SSH, no Git, no command line experience, no Docker, to being able to achieve the goal of the course, which is spin up, you know, full-on cluster, pulling data from a Flask app, dumping it into Kafka, pulling it out, flattening it with Spark, writing it to HDFS, and then, you know, using Presto or other tools on the back end to query it. So how are you going to do that in 14 weeks? So we started out just trying to get everybody to install Docker on their machines and blah, 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 blah. But just as a backup, we had decided to go ahead and provision some droplets on DigitalOcean, which is just their version of GCP instance or AWS, right, kind of services. So we provisioned those with a Docker file that, you know, could build an image that was kind of, we're like, all right, well, let's just have this image, which is completely not enigmatic Docker, but let's just have this image that will be able, they can do anything they need to in the course. So they always have something to fall back on. So what we did is have it be able to, you know, what it'll do is you can either join it as in RStudio or you can join it in Jupyter Notebooks. And honestly, I don't think I even thought this out too well at the beginning, but I was like, oh, right. They're all scared of putting a terminal on their computer and in Windows, which terminal are you going to use and blah, blah, blah. Well, just use the terminal in Jupyter Hub, right? So that way we could sort of begin to scaffold them to get to the point where they now, 10 weeks later, are in fact putting together all these pieces of this, you know, this pipeline, data science pipeline that they need for all their infrastructure. So just kind of focus a little bit on that. And a lot of what I think about with these kinds of projects is what I used to do a lot of research on when I was in academia myself, which was kind of where do these sort of tools scaffold you and where do you find them starting to be a crutch? And so what's that balance and for which courses and for which students and which problems? And the same I think applies to industry. You know, how is it helping us move things between development and production and where does it get in the way and how do we make those trade-off choices?
I'm Alan Downey. I teach at Olin College. That's our campus in the upper right there. We're in Needham. It's a new engineering school. Our mission is to fix engineering education. And it turns out that Jupyter helps with that in a lot of ways. One of them is in a lot of classes, exactly as Taylor was just saying, you can do a lot on day one if the students are not spending all of their cognitive capacity on being system administrators. You can be teaching exactly the thing that you want to teach right from the beginning. So that's been huge in a lot of our classes. A lot of the things that I do are the computational version of X for all X. And that's the theme of this book series that I'm working on, which is called ThinkX. So ThinkDSP is kind of like digital signal processing, except, well, here's an example of a day one. If you're teaching digital signal processing, you need to do a Fourier transform. You need to understand complex arithmetic. So if I'm teaching a mathematical version of this class and you're doing exercises on paper with pencil, day one is going to be complex numbers. Here's how you add complex numbers. Here's how you multiply complex numbers. This is not an exciting day one. If I give you a notebook and if I give you libraries like NumPy that know how to compute Fourier transform, you can, on day one, use your microphone, record a sound, compute its Fourier transform, look at that spectrum, and immediately start to understand that correspondence between a signal in the time domain and a spectrum in the frequency domain, which is 90% of what I'm trying to teach in a signal processing class. And you're getting that within the first 10 minutes of the class. What else is up there? Workshops as well, and that's, you know, what, as Taylor was saying, you know, what can you do in 14 weeks? Well, what can you do in 3 hours? And that makes it even more important to be able to dive in very quickly, get students into an interactive environment. Maybe just one last thought, and then we'll get to questions. Once you've got that interactive environment, you can do what I sometimes call maker pedagogy. Because when people started doing maker approaches to building circuits, that was a revelation to me as a teacher, because I had always thought bottom up. I'd always say, oh, well, you know, if we're going to make a circuit and we're going to light an LED, all right, I'm going to start by teaching you Ohm's law, Kirchhoff's law, we're going to analyze circuits. I'm going to give you a circuit, and your job is to compute all the voltages and all the currents, and then maybe you'll design a circuit. And then Maker, this approach was sort of a strange one. It just says, look, all right, we're going to build something. Here are the instructions. Put it together. Let's see if we can get it working. That's kind of step one. And then step two is you modify it. All right, so now put in 2 LEDs instead of 1. You still don't know anything about circuits, but you can try it, see if it works. We can debug. And then eventually get to the point where you understand enough to start designing things. I found myself doing exactly the same thing with notebooks, because I can give you the code, and at the very least, all you might do is just execute all the cells and see what they do. You don't have to know very much about how it works. You're just seeing inputs and outputs. And if that's as far as you get, fine, you got something. Step 2, you start tweaking things, change some parameters, see what happens. Step 3, start adding cells, start writing code. So it's a very quick entry point, but also a very gradual transition from using to designing.
Okay, so first off about context, and also, do you want to make this interactive as far as questions from the audience?
Absolutely.
Right, okay. So what we've done here, the panel has put together an outline of, again, contexts, themes, and challenges that we're seeing in using Jupyter in education. And we've marked down what some of the topics are here for discussion, but also this is intended to be interactive. So if you have questions about this, here is an incredible rank trust for using Jupyter in the classroom, especially.
So yeah, back when I was at UT Austin, I did work a lot with my library crew on this kind of stuff, because it wasn't, at this point, at that point it wasn't Jupyter Notebooks, but I can easily see it being that, because I was working with them on things like how to help students, how to do workshops for students on visualization, for instance, or basic computation, some Word, some Excel kind of stuff. Well, all that can be done in Jupyter Notebooks now. One of the most exciting things to me about libraries, though, and as O'Reilly is sort of like a library type resource, we provide 500 publishers' books on our website, is the possibilities for publishing using Jupyter Notebooks. So the idea that either academic publications, all kinds of publications, could come forward with so many more interactive elements, and then helping students figure out in the library context how to, instead of just you're writing a paper, how to present your own work using all those tools.
One thought about that, you mentioned carpentry, or software carpentry and workshops, helping people build that set of skills. I think there's a really important role there in computational science, broadly defined, that we have a real challenge now to make a lot of scientific results reproducible and reliable, and tools like Jupyter are very helpful for publishing the entire data analysis pipeline, not just the figures that got generated. And I have seen libraries in many places being the hosts of those workshops rather than academic departments, which is a little funny, but I think it's partly a mismatch between the training that those academic departments are doing and the skill set that you actually need to do that kind of work. So I think that's one potential really valuable role.
I agree with that. In fact, if you walk the halls of, I won't mention any particular liberal arts college, but and you ask, say, a mathematician or a computer scientist what they know about Jupyter, or you walk down to the other side of campus probably and talk to a librarian, chances are the librarians have heard about Jupyter, and they know about story maps from nightly labs, and they know a lot about how to take data from a spreadsheet and turn it into a timeline that you can visualize and really see the data. So there definitely are different skill sets coming out, but there's also, I think, a mindset that I would say that probably a lot of computer scientists are not big fans of Jupyter Notebooks. And there's part of it is the traditions. We're used to working in Emacs, and then you run your code, and the idea of you know, having a little bit of code and then an intermediate result and then some more code. Oh, but then going back and then changing that, removing a variable, and oh wait, now this code down here doesn't work anymore. It's a different set of problems, and I think you have to think about using Jupyter to tell these stories in a different way than many computer scientists have grown up with. So I found librarians to be just so open-minded about the possibility that I've been really excited about that.
I think they can be complementary. If the primary goal is to write a function that meets a specification, then an autograder works just fine. As you said, if the primary goal is to communicate a story, then probably we're going to need some human beings to evaluate that. But I think that can be complementary.
For me, autograding gets pretty exciting when we think about being able to offer not just multiple choice tests in an online environment, especially, you know, not just the online education that we have for O'Reilly, but, you know, I teach in an online program. So when your assessment choices are multiple choice, and multiple choice, that's not very great for learning. So somewhere that can give meaningful feedback on code at a large scale, I think is going to get to be pretty exciting. Well, I wonder here if it's almost less the university versus industry as what particular area, because I think it might have pretty much grown out of data science stuff. But that was true in both schools and industry. So I think now we're starting to see more move into production, more move into other kinds of subjects, more move into, I don't know, thoughts.
Yeah, I agree with that. I guess the idea of making code about a problem in the world is not necessarily the way that computer scientists have seen what they're teaching. And I think that's actually a really nice context for learning computing, to really turn that on its head. And I think a lot of the tools that we've seen with the flipped classroom, you know, making it less about lecturing at people, but allow them to learn through doing things, I think is a trend across all of the disciplines. And so even though computer scientists have been a little bit late to that game, I think having them work on that kind of, not that a student is standing up and talking about the code, but the code tells a story about a bigger picture. And so that really cuts across industry and graduate students and undergraduates, perhaps.
Maybe I can speak for, at least in engineering education. As I said, at Olin College, we're trying to fix some things. I can give you a quick picture of part of it. Part of it is the idea that any engineering problem is going to start with a set of people who have a need or an opportunity in the world. It might have an engineering solution that you then have to design, and then you have to get that solution out of your lab and out into the world. Mainstream engineering education focuses really only on that second one, and not the first part, understanding the people that you're designing for, and not the third part, getting stuff out into the world. So that's a big part of what we're trying to fix in engineering education. That's the what. And then a little bit of the how is, how many people here came through an engineering program? Okay, you probably had to do at least a year, maybe 2 years of science and mathematics before you did anything that actually resembled the practice of engineering. That has the effect of attracting a bunch of people who are not necessarily then going to want or be good at engineering. It also has the effect of deterring a whole lot of people who probably would have been great engineers who never get through the science and math death march. So that's a big part of the how that we're trying to change is real engineering, hands-on activity right from the first day on campus.
So one of my favorite areas of thinking and doing. I used to teach elementary school, and in 1998 I was teaching my 5th graders how to create websites, and what we did with it was make literature websites where they would, write their own works and put them up on the web. And then, we also did a math homework help site. So I've been kind of engaged in this question of, how do you get this stuff introduced young? I was at National Science Foundation for a while with the CS for All program. So I think if I were still in the classroom, and I've met at, various EdFu and other kinds of events, people who are using notebooks to teach computation, but really only from the middle school up. And I think I would be doing the same things I was doing in 1998 in terms of like, why not use Jupyter notebooks fairly young to create literary magazines, or to create ways to display data from, maybe you went and did one of those field trips where you collect Vermeer probe data and all this kind of stuff, and to organize things like that. And yeah, so at National Science Foundation I was definitely looking for ways to do that, and I think people are really starting to work on it, but it just opens up so many avenues. I get too excited when I think about it.
I'll say a word about the experiment that I tried using Jupyter Hub in a first-year writing seminar. It was, I guess, 3.5 years ago, and I was really super excited about this idea. I'm going to have students write, and they're going to read a little bit about something, and then they're going to write about it, and then they're going to make their own graphs and visualize the data. Wow, it's hard. And I guess I learned some pretty basic things. You can't just throw this into the classroom and expect students that are going to pick it up and run with it. So even the idea of having markdown cells, what? Is just, where's the spelling checker? How come I don't get a little red wavy line underneath words that are misspelled? It was really just completely, they were thrown out of their environment, which is not necessarily a bad thing. But there were a lot of skills about, going from top to bottom. I was really excited about the idea that, you hit Shift-Enter on text and it renders it. You hit Shift-Enter on code and it executes it. Well, that idea is not necessarily meaningful to tell them that their text is being rendered. So just the distinction between, markdown and rendered text was an idea that was really alien to a lot of students. So I think I'm with you. I get goosebumps too, but there's a lot of hurdles to get through, and a lot of concepts that are hidden that we don't think about so much, that working these tools into that set of students is really exciting and challenging. I'll just say quickly that every evening I'm engaged in a conversation like this because my wife teaches computer science in K through 12. And guess what her PhD is in? English. And she teaches computer science. So we talk about this every day, about how to do this. And I think we got the right idea. We just have to figure out how to get there. And a lot of work and money needs to be spent on it.
Yeah, I've found it a pretty smooth transition. So as I see, day one, they're executing notebooks, and they can gradually write more and more code as the semester goes along. If it's important for some reason that they start writing modules or scripts and they shift from notebooks into that kind of development environment, I think that's very doable. In some of my classes, they stay in notebooks all the way through. I think it all works.
The way that it really helped students to get going with the data infrastructure was to be able to start wrapping their heads around, okay, what is Docker? What is all this stuff you're throwing at me? And try it kind of piece by piece. And then we sort of broke down standing up one container, standing up two containers and connecting them, standing up containers and making data flow back and forth between them, etc. But it was just having very focused goals, and the part that it was really getting us over was the fact that we're going to throw a terminal, command line, SSH, and Docker at you and Git all in the first day, and still want you to do something. So after a couple weeks of that, and they work with various pieces of it, then you really they don't need to go through they still use their droplets a lot, but they don't use it through Jupyter Hub. They just SSH their droplets. So So I think it's really just figuring out what, but if I were teaching my old stats class again with Jupyter, I probably wouldn't focus them away from it, because the stats class I taught was very much for intro people, and I do all this stuff called inventing. So basically I would have situations where they would have to basically invent linear regression. I would do all of that in notebooks where they would have the data there and they could operate on it easily and see the results of their actions and do all that kind of stuff. Then do the regular lecture part and have them, move to doing it in other settings.
I'd like to add to that question too, the Yukon question. I actually heard a computer scientist say, I don't like Jupyter notebooks. It makes things too easy. And I think it gets a little bit to this question about, well, when do they wrestle with having to install all of this stuff? When do they, suffer that pain? I think we actually even called it pain. And I found that we don't really have to work the pain into the classroom. That they're going to experience that. And a lot of times, at Bryn Mawr at least, they're going to do that outside of the classroom. They're going to do it through summer research projects or working on some other task. And we don't really need to take time in the classroom that we could spend on learning something, a valuable concept, to work that into. So I would, the physicists, I think, were really interested about, well, when do they install their own stuff? And, they really don't have to do that. We can work that at a later time.
Yeah, and in general, just think really simply, you just hit a new topic, you hit a new area, you walked into a new class, and you're going to spend an hour just fussing around, I think somebody said, being a sysadmin on your own computer. That's not getting to the point of that class. That doesn't, you want to start out something new by drawing somebody into it. Then if you need to get to them installing a bunch of software, then you can get to them installing a bunch of software. But
so I've had the pleasure of being able to work with both physicists and biologists. So our physics department was a little bit behind the curve, that they really didn't have a computational story at all. So that they didn't really work computation into the physics degree, all undergraduates. So they started on a project a couple years ago about how are we going to come up with a coherent computational story across all classes. And I was sort of hired as an advisor for the project. And I thought, well, I'm going to give my advice, and I did. I said, well, I would use Jupyter notebooks, and I would use Python. And they said, okay. And they really didn't have an invested, they didn't have an axe to grind. They weren't using any computational tools, so it was a really easy recommendation for me to make and them to accept. And I will say that that project, the focus wasn't on it was a funded project by one of the groups that funds Jupyter, it was the Helmsley Foundation. And the project was about computation and working it into the physics classroom, but was really about diversity and equity. And that was really my suggestion for that. Was it's really, I see Jupyter notebooks, especially through Jupyter Hub, as a really nice, it has a nice backstory about equity. Things that, if you tell students to download Anaconda, install it on their laptop, maybe that their laptop, certain students' laptops might not be the same as other students' laptops. So being able to have a common server where everybody code runs was one level of equity, but then there's also the diversity and equity issues. And I see that a lot of this looking outside rather than inward, so rather than having assignments about computer science or about physics or about biology, it's really about how you take these computational tools and biology and physics, computer science, and work on a problem that's outward looking is really a nice step towards bringing more people into the field to have them excited about computing.
And on the gender question, I certainly think it could help, because the largest study so far, and this was in engineering departments, of why are women dropping out, why are they leaving STEM programs, was they basically asked, I think it was about 500 students, all of whom were women who were leaving, all of whom were getting A's, they were doing great in their programs. Why are you leaving, right? And the two top reasons were that they didn't like the teaching style, and then that they didn't see any use for the topics that they were being taught. And so I think, for a lot of the reasons we've talked about today, Jupyter can help in both of those, because you can much earlier in your program be doing activities, whether earlier in a certain class or just earlier in the program altogether, be doing activities that are more obvious what you would do with this, and honestly more engaging. So hopefully that should help.
Thank you very much for the panel.